Question number 5. The third line in the Balmer corresponds to an electronic transition between which Bohr orbit in the hydrogen? A 322, B 422, C 522, and D 622. Well, when we are speaking about the transition of electrons, whenever the electronic transitions, when the electronic transition occurs, when it occurs from a higher energy state to n is equal to 2, that time it leads to the formation of the Balmer series. Okay, now that means when a transition is occurring, let's say this is our energy level over here, this is the energy level, this is our first energy level, and that is our second energy level over there. Let's say these are the different energy levels. Right? Now, whenever there is a transition of an electron, and when the transition of electron occurs in such a way that it comes and falls on the second energy level, that time, whatever the transition, whatever the energy that has been ejected out, that energy corresponds to the Balmer series. Okay, now the third line from this point, this is a first line, this is a second line. Okay, that means n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, and n is equal to 6. So now, quite naturally, that is, transition is occurring right from n is equal to 3 to 2, that is a first energy state, 4 to 2 second, 5 to 2, that is a third. So over here, this is the energy state as what we are speaking. Now, this particular transition from n is equal to 5 to n is equal to 2, because it is the third line, okay, for in the Balmer series. It corresponds to the transition between n is equal to 5 to n is equal to 2. That time, whatever the energy that has been coming out, that particular thing, again, of course, corresponds to the Balmer series. And this transition is from the 5 to 2.